But each pulsar has a completely different rotational speed. The slowest rotates once every 9.437 seconds, and the fastest goes around 716 times every second. If we stood on its surface, we'd be going more than 97 million miles per hour. That's about 10 million times faster than we travel on Earth.
Every pulsar has an absolutely unique spin. It goes around at a given rate, and that's just like a fingerprint for an individual. So if you know what that characteristic spin is, then you know what that pulsar is.
Since all pulsars have their own signatures, you can use them as tools to determine your location in space, an idea that has been used by NASA.
Some of the spacecraft we've sent into the outer parts of the solar system, like Pioneer and Voyager, have had maps of space which show our solar system's location relative to the locations of a bunch of pulsars.
The pulsars in space can be used to locate the Earth in the same way that our GPS devices use multiple satellites to locate a position on the ground. It's hoped one day another race of space travelers will find one of the spacecraft and read the map to learn where it came from.
A sufficiently intelligent alien could figure out where we are by measuring all these same pulsars and figuring out where we are in relation to them, because each pulsar has a unique period.
The unique spin of each pulsar also makes them super accurate astronomical clocks, keeping better time than the best atomic clocks here on Earth.
Pulsars are so accurate because they're nature's ultimate flywheel. This is an ordinary bicycle tire mounted on a repair rack here in this bicycle shop. And this wheel is very much like a pulsar. Let's give it a spin. So you see the wheel is rotating very smoothly. There's very little to slow it down. Now for a pulsar in space, there's almost nothing to slow it down. Now notice that the wheel is rotating about a couple times a second. That's the average speed of rotation for an average pulsar. Now, of course, this wheel is only a few feet across, whereas a real pulsar is spinning at the same speed, but it's the size of Manhattan.
But nothing is forever, and even pulsars slow down over time, although they do it very slowly. The same bicycle wheel that illustrates the pulsar's spin also demonstrates what makes it slow down.
Pulsars convert rotational energy into radiation, and in the process, they have to slow down. Let's see how it works with the bicycle wheel. Now, the wheel is moving pretty quickly. If I put my hand to the rim, I can convert rotational energy to heat energy in my fingers. Ouch. Now the wheel has slowed down. In a real pulsar, it would be more like the action of a feather than my hand, because pulsars lose energy very, very slowly.